The global digital economy is expanding rapidly, generating immense value every second. Yet its most critical vulnerability is structural isolation. Decentralized assets often exist in a vacuum, separated from the physical economy. A hard boundary separates decentralized finance protocols from the daily, real-world purchasing power required to buy groceries or pay rent. Earning digital value is accessible. Spending it is significantly more difficult. Traditional Web3 mechanisms face friction. Pulsing DeFi nodes on the left attempt to pass value to rigid retail blocks on the right, hitting a bottleneck. Without retail integration, tokens expand in volume but shrink in mass, illustrating hyperinflation and value depreciation. When users attempt to push their rewards through that bottleneck, they encounter high transaction fees, complex multi-step conversions, and strict geographic boundaries that block the purchase of tangible goods. When a digital asset cannot be exchanged for physical goods, its value is tethered only to speculation. This makes the asset highly susceptible to the downward price pressure created by its own issuance model. Overcoming this isolation requires an architecture that links decentralized incentives with existing retail protocols. The Univex network is engineered to perform this specific integration. Univex operates as a decentralized financial hub, coordinating state logic and asset distribution across its network. Looking at this updated flowchart, the structural objective becomes clear. We replace the bottleneck with a seamless, automated bridge. This natively routes Web3 economic incentives directly into fiat-based retail infrastructure. This creates a unified economic engine. User engagement on the network converts into immediate global purchasing utility. To achieve this, Univex relies on three distinct structural pillars: a stabilized economic engine, a multi-layer routing infrastructure, and an optimized interface. Sustainable digital wealth generation is possible only when digital assets are linked to an automated, utility-driven bridge to the physical world. Before we map the software architecture routing these transactions, we have to engineer a stabilized economic foundation. To counteract depreciation, the Univex economic engine utilizes a dual token model. It splits the data stream into two circulating loops. Embedded within are automated reward scaling algorithms. When network activity spikes, they automatically adjust the flow rate, maintaining dynamic equilibrium. Direct payment integrations act as a critical release valve, finalizing the loop by allowing tokens to exit and convert into fiat. By running two counterbalancing tokens and a controlled release valve, the network reduces the extreme price fluctuations seen in legacy, single-token issuance models. These scaling algorithms continuously calculate real-world fiat parity, which helps maintain retail pricing at the exact moment of a point-of-sale transaction. Token value stabilizes because issuance is mathematically bound to dynamic scaling and direct fiat exit liquidity. Connecting that stabilized token model to global fiat retail creates an engineering hurdle. The system must process millions of concurrent user requests without latency. Traditional monolithic network architectures, where user interfaces and back-end logic share the same computing environment, inevitably bottleneck and crash under high retail throughput. The solution is a decoupled multi-layer infrastructure. Tilting into 3D, the economic engine forms the bottom layer. Layer A hovers above Layer B, isolating stress. If Layer A overloads, Layer B continues executing financial loops without interruption. This modular separation acts as a security barrier. Internal protocol logic is cordoned off, protecting the financial engine from front-end breaches. Without a decoupled stack, the system cannot maintain throughput necessary for secure Web3 retail utility. Let's focus on that top plane, the front-end interface layer, deployed as the Univex Super App. Built using cross-platform frameworks, it ensures deployment on a wide range of devices for global access. The client interface natively integrates cryptographic identity verification directly at the device level. Handling identity verification locally removes the delays common in traditional external KYC processing. Inside this dashboard interface, users track real-time metrics. They monitor live asset generation and the performance of their linked nodes within the broader network. The localized profile management system also visualizes dynamic referral tier point brackets, giving users immediate feedback on their network expansion efforts. Layer A operates as the secure sensory organ of the network. It gathers input and verifies identity, remaining insulated from complex financial logic. Once verified, user data routes straight down from the super app into Layer B, the decentralized finance hub. Plunging down through the grid, we enter the internal protocol layer. This isolated environment processes underlying state logic. Operating independently of the visual grid above, automated reward scaling algorithms execute at maximum speed, unburdened by UI rendering tasks. Within this hub, digital engagement is finalized into fiat-compatible data packets, prepped for external retail integrations. Layer B functions as the engine room. It handles the tokenomics away from the public-facing components of the internet. When the entire Univex multi-layered infrastructure is viewed as a whole, it operates in total synchronization. The sequence is rapid. Engagement originates at the super app on Layer A, is cryptographically verified, and is immediately pushed to the DeFi hub on Layer B. Layer B analyzes network load, scales the reward, executes the dual token logic, and outputs a stabilized value straight to direct payment endpoints. By enforcing this strictly decoupled sequence, the architecture achieves high throughput while maintaining strict security protocols. This sequential design allows decentralized assets to execute on physical fiat infrastructure without systemic friction. This architecture has global implications. Looking at these data lines spanning vast physical distances, we can see how the technology connects disparate economies. Implementing a unified economic layer creates a foundation for distributing digital wealth generation across international borders. Combining direct payment integration with scalability optimizes global remittances, allowing value to move instantly without high intermediary fees. The system bypasses the friction of legacy banking, offering direct financial participation to populations that were previously excluded from these markets. By engineering a functional bridge between Web3 incentives and real-world purchasing power, Univex creates a mechanism where digital participation results in immediate, liquid value.